Yes,
Yeah. So I will, yeah, from the slide. Yeah. I think, should I minimize this right side because what is this? I am seeing some people can see your screen. Okay, chat. I will close it. Uh, madam, madam, can you see what collapse? Yeah. Oh, now is the screen completely clear to everyone?
yes, sir. Yes, sir. It is clear. It is clear for me.
Yeah.
Any
I
others,
think.
please? I think it's okay, sir. Now,
Yeah. Okay. Fine. Huh.
right.
So we are here now. Fixed offshore platforms. These are compliant tower and this is tension-linked platform and this is spar and FPSO. So these are the various types of offshore structures that are constructed inside the ocean. And okay, the same representation I am giving you here. Collapse. The same representation I am giving here. So this is the actual live picture, how it exactly looks. Maybe this is all the animation that I have shown you. So, but this is the actual structure, how it looks like. So the yellow part, whatever you are seeing, is called jacket, and the white part, whatever you're seeing, it's called topside. So let's see some more fixed offshore platforms. Yeah, the same one I have just shown you in the in a big scale, bigger scale. So again, I say this yellow part, whatever you are seeing, it's called jacket, and the above part, whatever you are seeing, is called topside. So in the meanwhile, audience can think how this structure is placed inside the water. Have a think on that, and we will come back to that point in in later time. And this is the same one more platform that I am showing you. So same thing here, the color code is not there, so everything is yellow. But until this point, wherever my cursor is, that is called jacket. Above that is called topside. And I want to highlight these four lines, four yellow cylindrical structures you are seeing, right? 1, 2, 3, 4. Backside also it will have another 4. So these are called conductors. These are called conductors. That so inside the conductors, that means, okay, for a layman language, these are the actual 4 tubular members or 4 CHS members in the circular hollow sections where it extracts crude oil from the ocean. 1, 2, 3, 4, and backside also we have 4, totally 8. Otherwise, in a normal language, we call wells, oil wells. So that means below this structure there is an oil well beneath the ocean, and from the well, these 4 tubular members will extract the oil from this below, from the well below. Going next, again, just think how this is placed in water and how the extraction is being happened. And one more typical picture for wind, offshore wind. So these are called offshore wind turbines. I think you might have seen this type of wind turbines on the land, but in the ocean also a lot of wind is being wasted. So that's the reason we want to use that wind to generate power to most of the countries. So almost 50% of the energy that is used in UK and some other countries are dependent on only on wind. So they generally construct all these things in the ocean, nearest ocean, and they used to generate. And this is one substation. Like this, we have wind for one substation is required for every 50 to 70 wind turbines like this. These are all wind turbines, whatever you see. So this is rotor and this is the blades we call. And the whatever yellow part you are seeing, right? The yellow part here. So you will be designing this. That means all structural engineers will be designing this part and this part, this vertical white part. So this part and the blade and fan, just blade and fan will be generally supplied by the vendor. Just a second. Just a second. Sorry. Just Yeah, so, sorry. Sorry for the small disturbance. So there is one interesting point here, and one is one interesting fact, I say. So to design this structure, the yellow part, whatever you are seeing, it will take in our software. It will take a minimum of 3 months. 3 months is required just to analyze this. That means, for example, you might be knowing STAD, other softwares, SAP, or and Revit, or maybe SACS, some of them. So when you click analyze in your software, it will hardly take few minutes of run. That means it will analyze the structure, it will run, and it will show you the member displacements, member stresses, whether the member is failed or not. Okay, it will take hardly maybe 5 minutes or 10 minutes. Sometimes if the bigger structure, it will take half an hour. But to analyze this, to run this program in this software, it will take 2 to 3 months a minimum time. So if any changes, for example, if I want to change a member size of this member, and again if I want to rerun, it will take another 3 months. So that's the criticality of this wind, yeah, wind turbines. That is a I can say it's the biggest drawback. But yeah, it's under research, so there is no other option as of now. So this is FPSO. That means what I have showed you in the previous picture. What I have showed you in the previous picture. I'm going back to my previous slide. So this one, whatever you see here, this is called FPSO. It's it looks like a ship for a normal person, but we call in a technical term we call FPSO, floating production storage and oil. I'm going to the current slide. Yeah, FPSO. It's called FPSO. It will extract oil from the ocean. This is especially used when the seabed is maybe some hundreds of kilometers away. It will extract oil. It can extract oil. Yeah. Coming to a brief terminology, as I already told you, the substructure part is nothing but jacket, and this is called topside, or we can call as deck sometimes. And this is flare boom, quarters, especially living quarters. People stay there in the oceans. People stay there, and the foundation is done by piles. And the typical, yeah, I think I covered everything. And if you observe here, 1, 2, 3, we have it's a four leg jacket, but supported by the skirt piles. We have four-legged, three-legged, or eight-legged. There are different configurations of the jacket, and this jacket is generally used for the maximum depth of 400 meters, 400 meters of water depth, and it can be up to weight up to 50,000 metric tons. The weight self weight can be 50,000 metric tons. Self weight means don't assume only steel. A lot of equipment will be there inside, including all equipments. It can bear until generally until 50,000 metric tons. And the fundamental natural period is less than 5 seconds. We will make sure that the fundamental natural peak we will design in such a way that the natural frequency or natural period should not be more than 4 to 5 seconds. The reason being is the wave time period generally is within this range, 4 to 5 seconds. So in order to avoid the resonance effect, we generally make it low. We generally go to 2 seconds, maybe 2.5 seconds, 3 seconds to the max. Not encouraging, we will not encourage more than 4 seconds. Again, previously it's animation, it's a live picture. Whatever, yeah, here again, whatever yellow portion you are seeing is called substructure. It is called jacket, and whatever the white or whatever the above portion you are, it's called topside, and this is called flare boom. That means whatever poisonous gases that sometimes while we extract oil and while we extract uh, oil and gas, sometimes poison gas also it will be a part of that crude oil. So that crude oil, whatever the poisonous gas, we will flare it here, we will fire it here itself, because it should not be transported to next phase. So we'll fire it here itself. That is called flare boom. That the reason. So since it will fire, so we will maintain a certain distance away from this platform. So that's the reason it will fire here. And drilling is a crane. You can see the crane here, right? A small crane is here. And here we call living quarter. People stay there here for years together. People stay there here. These called living quarters in the ocean. And lifeboats. This is the lifeboats. If anything emergency happens, people use this lifeboat and they will jump into the water. And yeah, this is called jacket that I already told you. And this helideck, choppers, helicopters travel here. Yeah, this is one or this platform name is ZCC, Zacum Super Complex. Sorry, Zacum Central Complex. So this is my regular site that I that I visited in the Abu Dhabi waters, Abu Dhabi ocean. So I visited this platform for 2 years continuously. And 2 years I was intermittently traveling. That means every month I will go to site for at least 1 week or 2 weeks, and I will do my work. I'll do my works there, and I'll come back to land. And this platform is around 106 kilometers away from the coastal line. That means from the seashore. So it is 106 kilometers inside the ocean. And just think how much big this structure is. This is the aerial view taken by me from the chopper. It's aerial view. So, but if you ask me the dimensions, okay. So from tip of this to tip of this is around 490 meters. That means near to half a kilometer. So that much vast it is. And whatever, okay, I will come back to this point. Yeah. In the meanwhile, audience can think how this massive structure placed in water and for how long. Yes, how long they will keep on placing this. And this antenna, whatever you are seeing, is something like BSNL phone internet connection. I mean, there we call Etisalat network, but here, yeah, just a simulation. We can call it a BSNL tower. Yeah, as you can see, helicopters, choppers here. And yeah, I will come back to this picture in the later slides. And this is one of the heaviest decks in the world. So the deck itself is around 35,000 tons. 35,000 tons is there. The whatever white structure you are seeing, it is 35,000 tons. And whatever red structure you are seeing, it's called jacket. See, my session is mostly pictorial, because since it's a short time and people has to grasp the knowledge within the given time. So I will that's the reason I am using most of the time with pictures and images and animations rather than writing something on the slide. Yeah, this one more jacket. This red color one, what you're seeing, is called crane, and these are all white color one, what you will call risers. I'll come back to this point. These are all called risers. White color portion, what these are called risers. Basic industrial terminologies, most of them might be knowing what is client and what is contractor. And only thing I want to make you know is different disciplines people work, because people think oil and gas structures means only civil engineers. No, it's not civil engineers. It process piping. Unfortunately, there is no separate department in India where process engineering and piping engineering is not famous in India. Hardly one or two universities are giving these courses. I mean to say pipeline also. These three courses, but if you go to abroad any other places, so generally they have separate BE course for this process and piping. And yeah, electrical instrumentation, architectural, mechanical, civil, structural, safety, corrosion, package, and IT electronics. So all these engineering departments are required to build that structures. And what are the wings involved? Wings involved means, so we have engineering office, we have fabrication office, we have site office, we have PM's office, project monitoring control, and we have vendors, third parties, certification authorities, etc. And on everything on the top we have client. So these are the wings involved. In every wing, whatever disciplines I told you, whatever departments I told you, everything is involved. That means in engineering, in fabrication, site office, in site office you will have piping, pipeline. Every department is involved in all wings. So that is a it's a kind of a massive teamwork. It's a massive teamwork. Other than this, we have these are technical technical people only. Other than this, we have exploration team, we have drilling team, we have chemical engineers, how to deal with crude oil. Yeah, these are all there in all wings. That's what I told you before. Yeah, and engineers and designers. Both engineers will be there, designers will be there. Designers will generally make the drawings, and engineers who decides the dimensions. Okay. Comparison of offshore platforms. What I am doing here is, see, this is the Toronto Tower, 1815 feet, and I think the most famous one is CS Tower in Chicago. So this is 1454 feet. So I just want to tell you how much big are these offshore structures. So on the land, if you see, compare, this is the water level, and this is the this is the water level here. So you can just assume this shell, Bullwinkle Will is 1615 feet, and this is 1265 feet. So it is almost crossing this CS Tower on the land. But on the sea, you will see only the top part. You cannot see whatever below the water line. Yeah, water level you cannot see. So people think that okay, this is only a small structure. No, beneath the water level, this is this much tall, this much deep. Okay, I will share my experiences. This is a uh, we call Palm Island in Dubai, and on every island, this is a man-made island. These are called palm. We call Palm Island leaves. We call palm leaves. We call on every leaf we had a construction. And Burj Al Arab is one of the costliest hotel in the world. So in the similar way, since it's a man-made, it's near to the city. From the city, you can see this island. So this is a man-made island. In the similar way, we have built this island inside the ocean, 200 kilometers from the coastal line. 200 kilometers of coastal line. We built this structure. So this type of islands we made, almost 3 or 4 islands we made. That means, so here only the refining happens. From here, from the this is a very old picture. So in the latter stages, you will find one more structure here. The structure will extract all the oil and gas here, and the initial refinement happens here itself, inside the ocean. After the initial transfer happens, it will transport oil and gas to the cities. From there, the distribution happens. So whatever here the rocks you can see, so whatever the rocks you see here, these are the rocks. Whatever I showed you is one of the boulders, I can say, very huge boulders. This one, the boundary. The I think everyone knows this Ram Setu bridge in Ramayana. So they used to first put a big boulders of rocks followed by the smaller rocks. In the similar way, this island is constructed inside the ocean. So yeah, this is one of the same way picture. And whatever you are seeing, this is a refinery on the land. I just want to show you how the refinery looks on the land. Yeah. So discuss oil and gas, PLC, H2S gas. So I told you that this is one of my sites that I visited for 2 years. So this is a process platform. We call this as process platform. And what are small structures you are seeing right here? 1, 2, 3, like that. Around this structure, we have around 50 or 60 platforms like this. So these are called wellhead platforms. WHP. This one, and there are so many because all are not visible here. There are so many other platforms, small minor platforms compared to this big platform. So what it does, so these are the actual platforms where it extracts crude oil or gas sometimes. So whatever it extracts, it will pass all this oil beneath the ocean on the seabed, and it will travel. It will start pumping here. So from here to here, refinery goes in a phase by phase. There is one refinery here, one set of refinement, one more set, like that. It will travel from here to here, and from here finally it will travel to the city. So that is the way it generally happens in this sector. So whatever the oil and gas, it is extracted here. So don't think that person will go inside this platform and he will start extracting. No, it will not happen. So single person is a head for this all platforms. That means one person will be sitting in this called PLC. There is a PLC room here. That means a PLC room is containing some 20 to 30 monitors of the screen, observing the pressure, temperature, and he will code. That means software code. He will write a code for that one, and he will make sure that if the temperature crosses of the crude oil, he will stop extracting. That means we have to maintain a temperature limits and pressure limits that is to be entered into the offshore platform. So if any time the pressure is high, we need to switch off that platform. That means by the single command here, with a single button here, with a single switch, you can control all platforms everywhere. So this platform, particular platform, I heard it is covering, it is managing around 35 to 40 wellhead platforms. So whatever oil and gas it is getting, it will come here and it will maintain. So that is the beauty of this one. So that means IT is having the key role here. The information technology guy who is sitting here, he is highly paid and he will be controlling all the platforms. So coming to the H2S gas, I think most of you might know hydrogen sulfide gas. It is mostly generated here because of the refinement, ultimate refinement. See this structure. It is very very massive. At the same time, it is very very there is no space. Once you go into the platform, only at a time only one person or two person can walk. So that is the level of the complexity inside the platform. So here the problem of this particular end or particular wing here is it will release H2S gas, and the disadvantage of H2S gas is if the H2S gas limit crosses its intensity, we cannot sense the gas. If it is in a smaller limits, we can sense it and we can quickly evacuate. But if it is in a larger amounts, H2S gas sometimes if it produces in larger amounts, our nose cannot sense it. And the problem with this, within a minute the person will die. Within a minute. So this is something like a very danger alarm. So we maintain all the H2S alarms, we maintain all that equipment, and we'll enter this zone. So the moment the alarm rises, we should stop breathing and we should run from this platform to somewhere to the near side. So that's a dangerous problem here of HTS gas. And yeah, I want to show this simulation. Everyone knows this is a car bonnet and is a machine. Whatever you are seeing here, how complex it is. That means here only one ant can enter, right? In the similar way, only one person can enter here. That much complex inside. So I just want to simulate. I just want to make you to understand to a normal person, to a layman, how complex inside it will be. In the similar way, the complexity will be inside this platform also. And one more thing is here we have choppers, everything here, and people daily come visit, go, and all the food, everything will be served here itself. If you observe, if you can visible in your screen, here we have basketball court. We have almost all facilities here. We have movie theaters inside, we have basketball courts, we have internet centers, we have ATM centers. Here this is the accommodation platform. These two are accommodation platforms. Here 1,000 people stay and here 1,000 people stay. So at a time 2,000 people stay here, and every day they work 6 to 6, morning 6 to evening 6. They start entering this bridge and they will distribute their work. They will go, some people go here, some people go here, some people fly from chopper, some people fly from they will travel with ship, boat, and they will go to other platforms like that. That is there. So since this is a very huge platform, every client will make you every possible facility, and everything is there. That's why I told you cinema halls are there, basketball courts are there, saloons are there, no, and snookers, IT, everything, all type of entertainment is available almost. And only trained person will be entering into it's something like a military zone. No no layman person or uh, nobody can generally visit this site. Only trained. We are under we will be under rigorous training for 1 week. Then only they will give a certificate, yes, this person is eligible to enter into the site. Then only we will be entering the site. Yeah, going to the next picture. Yeah, so the same picture I showed showed you in another way. Another way. So this is a complex structure that I am talking about. These are same accommodation platform that I told you. These are rigging platform. Most of you might be seeing in movies. A rigging platform. Maybe another view. That's it. Nothing new. Yeah, I am here taking the measurement to your site, and these are same accommodation platform. The backside, what you're seeing, I'm working on the uh, main working platform. This accommodation platform is working platform. Going next, yeah, discuss bridge. Yeah, I told you about the dining, whatever, helipad, and facilities. Also, I gave you a brief introduction. This is a crossing bridge. Every day we morning we start and we'll start working. And dining is excellent here because all different nationalities work here. Don't think only Gulf people will stay here or only Americans stay here. No, all nations will be working here at a time. So food will be food will be excellent here because all every day there is a buffet. Every day there is a different. The chef will make you different items, and fresh fish will be available. No doubt in that. Yeah. This is the bridge that I'm talking about. See, this is the bridge. This is the bridge that I'm talking about. Somebody took the picture from here, and whatever you're seeing, these are girders, I-section girders. So I-section girders, and I just want to give you a brief information on this girder. So this platform is constructed in 1980, and it took 5 years to construct completely, or to build here, or to bring here, whatever you call install here. So 1980 to 1985, this construction keep on happening here. So at 1980 and 1985, we don't have that available good softwares at those times, and they have designed this complete structure, and this depth of this I section is around 4.5 meter. That means crossing one floor of one floor. When you see any apartment or any building, bay to bay length is generally 3 meters, right? So it is crossing this I section depth itself is almost 4.5 meter. Yeah, just a second. Yeah. So that is 4.5, and you can just imagine in 1980 there is no FES software and anything, but still just by hand calculations they have built this structure inside the ocean. Yeah, going next. So these are anodes. That means the picture taken inside the ocean below the water level. So these are called sacrificial anodes. That means you might be wondering, right, how this structure is placed, or how structure is surviving in the ocean for this many years. Corrosion will happen, right? Rusting will happen, right? So corrosion is a threat to offshore structures. So in order to control that corrosion, we generally go for this anodes. So these are called anodes. That means before this jacket structure or before this member started corrosion, this will transfer this corrosion to this anodes. It will transfer all this corrosion to anodes, and it will protect the structure, and itself it will corrode. So this lifetime is generally 10 years, 15 years. So every 15 years people will go inside the ocean and they will again install new set of anodes here. And whatever you are seeing is all marine growth, that means algae formation. And every 5 years a diver will go inside the ocean and he will clean all the algae, because whenever this algae is increasing, that means the diameter increases. Whenever diameter increases, structure will absorb more waves. When structure will absorb more waves, it is not good for the structure because it will create more base shear, and it will create more more overturning movement. It is bad for the pile foundation. So in order to avoid all those things, so generally a diver will go inside until the bed seabed, and he will clean everything. And remember that diver is highly paid. Yeah, general industrial terminology, I think I have given what is jacket, what is topside, and what, yeah, I think you might be knowing what is chopper and helideck. Yeah, and how these piles are constructed or how these piles are installed. So the yellow portion, whatever you are seeing as jacket, so generally two or three types we can say. So generally a pile, because you know that all the jacket members are generally 99.9% they are CHS tubulars. That means circular hollow sections only. For being its for being having its unique properties, they will have the less drag and inertia coefficients, and they will have the equal properties all around, and they are very torsionally rigid. So having that all things in mind, so we generally go for circular hollow sections, and the piles will be inserted inside that hollow region. That means wherever circular hollow is there, inside that hollow portion we will insert one more tubular. This is a bigger CHS, and this black color one is smaller CHS, that will be inserted inside the jacket leg, and that will be, this is a seabed, and that will be driven and below the seabed. So we will arrive at the our required destination, because we already, we as a structural engineer, we will decide what is the depth it has to be arrived. So until that arrives, we keep on hammering it. So how and one more set is, yes, people will be sometimes people will not be interested. Sometimes the jacket is too huge, too tall, so client will be thinking of the money. So instead he will plan one more, something like pile here we call. I will show that in a pictures. Yeah. So the blue color one is whatever you call C is jacket, and the red color one whatever is pile. So this pile will be inserted inside the jacket leg. That means inside this yellow leg, we will insert this black color member. So the same way, yeah. That means piling is happening here. So this hammer comes and it will continually it will hammer it until it reaches its desired length. Yeah, you just see the man size compared to the pile. You know, just see it. And these are cut pile arrangements. So this is a jacket. This is cut pile arrangements. Yeah, this is called jack-up rig. That means this is my jacket, and this is the top side. It is ready. Now you might be seeing this type of structures in movies, especially in Hollywood movies. So what is the actual duty of this rigging? We call it a rigging platform. What is the actual responsibility is? So this is a movable platform. You need to understand this. So this whatever portion of cursor I am moving, this portion can go up and it can go down. When it goes down, it will what it can do. It can that when it is going down. Other words, this whatever structure you are seeing, this three legs, it will go up. That means it can, once it reaches the water level, automatically these legs will go up and it will travel to another place. That means wherever it wants to stay, it will stay, and wherever there has a work, it will go to travel, and they will perform the task at that in that site. So the reason for here it has already is, they are performing the drilling mate. That means I told you the conductors in the previous slides. Conductor means where the actual tubular members, which is extracting crude oil from the ocean. So in order to do that, it is in a simulation, in a layman language, what I can say, we generally do the boreholes for the water, right? We call boring. We are performing boring activity near our home, near our house, or in our land, just to extract water, right? In a similar way, this is the boring activity or the drilling activity to extract oil and gas from the ocean. But it is too complex, because it can be few hundred meters to kilometers. It will drill few kilometers below the ocean, and most of the drilling happens these days horizontal drilling, not vertical drilling. That means up to 500 meters, up to 1000 meters, or up to 1 kilometer, it will go vertically down, and afterwards it will go horizontally. It will go horizontal drilling. Yeah, again, this is a drilling rig. Where is the cursor? Sorry. So this is a drilling rig, the real picture of drilling rig. In the similar way, onshore, whatever you are seeing is offshore pictures now. This is onshore. That means in the similar way, onshore, we drill the rig here and we extract oil and gas, and it will extract it and it will keep on extracting for its lifetime. See, this is the actual picture. This is the actual picture that I have shown you in animation. So, so this keeps on extracting the oil and gas. This keeps on extracting oil and gas. So this country is called Brunei, Brunei Darussalam. It's near to Singapore. So the beauty of this country is uh, within 5 kilometers, or sorry, within 5 meters or 10 meters below the land, instead of water, it will have oil. So that's the beauty. So we just parked our car and just on the right side of the on the parking. We just parked our car and went to. We just walked, I think, a few meters, and we found this like this. And in that country, it has many. So that's the reason the government has put a condition that whatever land you buy in this on this country, in this country, so whatever is available in the first 5 meters, it belongs to the owner, and anything available below 5 meters, it's belong to the government, because the most probable case is below 5 meters you'll get oil resource. So that's the beauty of this country. And you might be knowing Brunei king was one of the richest person on earth. So that's information. I told you that the conductors and different types of conductors. So these are the conductors which is inside the conductor. A small 1 inch pipeline will be going inside the below the seabed. That is actually extracting the oil, and this above portion people will control. Yeah, I will try to show the drilling animation if time permits. And crane hook. So this is a crane hook. You might be seeing on the land how cranes are, but just see this is just a point. So compare the man size, compare the hook point. I will show you in the next picture how this hook is being used. So this design is a mechanical part. This will be done in usually done in abacus FEA software, and these are called slings or ropes. Now these ropes will be attached to this attached to this hook prongs, we call hooks. So this is the hook what I showed you. I have showed you what this is a hook. This is the same hook. The same hook is used to lift a topside. I'll come back to the how this is sent into the ocean. I didn't tell you how it is installed. I just asked you the audience to how to think how the structure is placed inside the ocean. So this is a hook we usually lift and we'll keep it inside the water. I will come to the sequence in the next slides. Yes, I just want to highlight here the hook size. How much hook we are doing? What is the size? Just to get the feel. People think that this hook is very small from a from an aerial view or from a longer distance. They think, oh, this is a small hook, just okay, this is just a lifting, it's like that. But no, see see the links also, you cannot lift these links. Separate cranes are required to lift these links to keep on here, that's the condition. Yeah, now it's just lifted. I will discuss what is padding. Yeah, so these links, wherever you're seeing these links, you are seeing the hook point, but where it is connected to the to the bottom of these slings, these are called slings. Whatever ropes you are slinging is called slings. So the slings are connected to the top by a hook, and how it is connected on that platform, there should be some location, there should be some small accommodation for this slings to attach here, right? So those are called paddies. So these slings are connected to this paddy. That means those ropes will go inside this hole. And again, see the size of this person compared. He is welding this paddy here. So the slings will go inside this rope. The rope will go inside this hole, and the top one will be connected like this. 4 or 5 paddies will be there for a structure, because if you see here in this platform, we have one, two, three, 4 ropes. That means 4 paddies will be there here. One, two, three corresponding paddies will be there here. And boat landing, yeah. What is boat landing? So, for a chopper, you have helideck to land, but for boat, how to land, how to come to the platform, that is called boat landing. That means your helideck will be chopper will be designed. I mean, the helideck will be designed. I think helideck I can't show you now. I think I have shown you in previous pictures. So the helideck will be designed for all the vibrations and the landing impact loads of the chopper. In the same way, every structure is designed a proper boat landing system. That means when a boat comes, when a ship comes and impacts the structure, as a structural engineer, we should able to withstand that load because it will comes with some certain velocity, and sometimes accidents may happen. The pilot or the driver who is managing that boat may lost his control, and if it is to the structure, so how the structure behaves. So for that one, we generally do a non-linear static analysis in our software to deal with that. So that is called boat landing arrangement. The same barge jumper, same thing, something like shock absorbers to help this boat landing, and riser protectors. I'll come back to this. And the pipelines, we have piping, pigging, pig launchers, and receivers yard. So what is this pigging and piping? So it is something like that. In your the pipes will be all your oil and gas will be generally traveled through pipelines. So that crude oil is having so much of dirt and other pollutants. So it will in a given span of time, maybe within a month or maybe in a year, what it does, the dirt and dust and all the particles will be accumulated in the pipeline, and such that it will not. It's something like a blocks in blood vessels, right? It's something I think everyone knows this angio and everything. I'm just trying to relate this one and to make it simple. So it's something like a blocks in our blood vessels. So when our blocks happens, what we do, we generally go for stent operation. Stent. In the similar way, this pigging is something like an equipment. It will travel. I will show you a picture of that. So this is pigging. So this is a intelligent pig, PIG. It's an intelligent pig. It will travel from the start and end of the pipeline. That means the pipeline, let it be 1,000 kilometers pipeline, let it be 2,000 kilometers pipeline. It will clean from the start to end of the pipeline. That means it will start here. That means called pig launcher. We call pig launcher, and somewhere you. That means we if we launch today, maybe after 30 days or after 10 days or after 15 days, somebody will receive it at the other end, because it has to travel a lot. It has to travel so much distance, right? So this is one of the very good technology people are using in the current industry. So sorry. So once they start this machine, it is so intelligent that at every 1 meter precision, or every that precision we can decide, at every half meter or at every 100 mm, it will keep on giving the thickness, because what happens in the sea, corrosion will generally happen. Because of corrosion, what happens, holes will happen, and because of holes, leakage will happen. If leakage happens, there is no use of this extracting oil, right? So because people will be spending a lot of their efforts, and they extract oil, and they will be transferring to the cities or to the nearest towns. If leakage happens inside the ocean, no one can identify that. So it's a waste of work and waste of energy. So because to avoid that, we use this intelligent pig concept. It will create, it not only cleans, it will try to give it will try to give the dimensions and the cross section sizes at every half a meter or 100 mm, whatever you decide. So anything happens, or anywhere the intelligent pig says, okay, here at this particular section, at this particular length, this particular length, this cross section is almost having to the corrosion. That means it is almost to corrode. It will immediately pass its longitude and latitude to the PLC person. And I told you PLC will be that IT by will be all dealing with all this type of technology. It will give the longitude and latitude of that uh, region. Immediately the diver go and he will correct there. So that is the concept of the intelligent pig. Yeah, just one picture. Now coming to slightly, I'm increasing my content. I'm slowly, I think by this time you might be knowing what I'm going to talk in next session. I'll be slightly touching the technical part, how these how we will design for this, how the structures will design for this, and what different types of structural analysis we perform in this offshore industry. I'll be dealing into that, and what lives we'll be having in the offshore life also. So just to start with a brief before the clock strikes 11 o'clock. So we generally have these loads in the offshore structures, gravity loads. That means structural self-weight itself. We have equipment, we have piping, we have electrical, we have instrumentation, HVAC, safety. These are all gravity loads. That means whatever loads we have, we generally apply on the structure, or it is generally existing on the structure. And what other the it is something like that. Your the for every structure in your for any structure you decide, there will be one critical load. That means, for example, if you suppose if you want to design any transmission tower in the remote area of the city, so the critical load of the transmission tower usually is wind load, because there is no other load. Because self weight, yes, we will design properly, but the only critical load that we will worry about is wind load. But for offshore and whatever residence we are living in, we generally worry about the self weight. We'll design generally for self weight. If it's inner region, it is designed for self weight. If it's a remote area, we'll worry about the wind loads also, and depends on the height of the structure. If the height crosses some limit, especially 10 meters and above, we generally worry about wind. Otherwise, for small structures, we'll generally not worry about the wind, and we'll design for the self weight itself. And the critical loads for this offshore structure is environmental load, other words, wave load. So wave load is critical for this offshore structures. So the major challenge is to create a proper jacket. I mean substructure. In the next session, even if I use substructure, means which is called jacket, foundation means we call piles. So the substructure and the jacket and piles, the major challenge is to withstand the proper waves, because the wave hits on the structure will be safe, no doubt. But all those loads should transfer to jacket, from jacket to piles. So ultimately your jacket, it's something like a foundation. Your jacket and pile should be withstanding all your wave loads. If that is withstanding, then there will be absolutely no problem to the topside structure. So waves will be there, 36 meters high will be there sometimes, and wind will 240 kilometer per hour, and you have current speeds, you have hydrostatic pressure, you have seismic, you have snow and ice, especially in UK regions. Other than that, you have accidental loads. You have boat impacts. Ship will come and suddenly hits. The structure will vibrate and the boat landing will collapse. Jacket will collapse. So many accidents will happen because blast is a usual thing. It's a common thing because we are dealing with crude oil. It's highly inflammable. So a small friction can lead to accidents and drop of objects. So sometimes when the crane operating, what happens when it is crane is lifting the heavier objects, it will sometimes, due to the crane failure, it drops. So it drops when it's dropping again. It's a non-linear dynamic steady. So these are all generally things happening. These are the exceptional criteria, but these are day-to-day criteria. Just because this waves acts every day, you know. So that's a challenge here. We need design for the environmental loads. So we know everyone IS 456 and IS 1893 and IS 800. I mean, I'm talking about Indian codes. Other than that codes, what codes we know for onshore? For onshore, if you work for I think everyone knows AISC, American Institute of Steel Construction. We generally design AISC. And what other onshore codes we generally use? generally deal with for onshore. And we have ACA code, American Constant Institute. I mean for a concrete structure, and for steel structure you have AAC. And what is for UK codes, British codes, what you will use means we generally use Euro code EC3, right? We call EC3. And for offshore structures, these codes are generally used. So what the top side portion? Top side portion is similar to your onshore structure design. That means you use EC3. That means you use a IS 800. But for the below, whatever the jacket or the pile foundation, those codes will not apply, because these topside and etc. will be not having that wave effect, because we will maintain the structure in such a distance that the highest wave will not reach that. So that's why generally this topside structure will be designed as per your IS 800 generally when it comes to India, but no one will rely on IS 800. So we generally use normal steel structure code that is used for onshore design. But for jacket we use special codes. What are those? We will just see. So that is nothing but API, American Petroleum Institute. So that is the code we generally do for the design of jackets and design of piles. And we have another codes. Nothing but NORSOK, NORSOK. I think I didn't mention it here due to the time frame we didn't include here. So NORSOK codes, NORSOK, and we call DNV codes. It's a Norway code, Dutch and Norway codes. So these three codes are of prime importance, and four codes, including this ISO codes, International Standard Organization, API, and NORSOK, NORSOK, and DNV. So these five codes are currently ruling this industry. We need to go local government regular organizations. That means local government regular organization means they have some certain rules. Sometimes no structure should be built within 100 kilometers from the seashore. There are some local government organizations, and these codes will vary from country to country. It's something like that. So the headroom height, for example, the headroom height in India we generally maintain bay to bay height is 3 meters, right? But in China it's different. In Abu Dhabi it's different. In Abu Dhabi we have seen 5 meters, 5 to 6 meters bay to bay. The ceiling will be too high. If you go to any apartment in Abu Dhabi and Middle East, the ceiling will be too high. We'll surprise to see too high, because they generally maintain a lot of ceiling. I forgot the term. Ceiling fan or not fan. They don't use fans. So yeah, they use a lot of ceiling equipment, lighting equipment. So they generally maintain 5 meters bay to bay height. And if you go to China, the manhattan is less compared to UK or India. So they mostly the China or some other countries, the manhattan is small. So based on that, the height variation, dimension variation, the codes will vary. And you have Petronas, Shell, ExxonMobil, British Petroleum. These are the general own specifications. Because on top of that code, you need to implement, or you need to make sure that we are following these codes also. So there are a lot of codes are there, and lot of these are classification bodies. That means these people will come and check. Once you build your structure, these people will come and check as a third party, something like a third party. They will do, yes, you have you maintain all the code provisions based on this API, based on this Petronas, Shell, whatever. So these will come and again give a certification. uh, yeah, madam, I think it's 11 o'clock. Where is this? So can I take a break, or shall I come back off after 10 minutes? Can anyone reply? Hello? Hello? Anyone there? Hello? 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 Can anyone respond? I'm just taking a break, and we'll meet at 11:15 or 11:20. I'll come back after 10 minutes. 11:15. Let's fix some time. It's 11:05. So I'll just take a break of 15 minutes. I'll come back at 11:20. So oh, what is this? Uh, uh, named Roshan. Private? Oh, no, 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 no. I want to message everyone. No, 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 no. Coming at 11 again. Yeah.